Hello everyone, thank you for checking out this video. You are with Coach Deathbot from 32 Academy.
Let's read the question together. So the question says, find the total number of sets of positive integers x, y, z, whereby x, y, and z are positive integers in a strictly increasing order. So x is smaller than y and y is smaller than z. And the second condition is that the sum of these three numbers, okay, x plus y plus z, is fixed at 203. Okay, so how many such solution sets are there technically, whereby x is smaller than y, smaller than z? So one possible case, probably x is 1, y is 2, and z is 200. Okay, that's one such solution set. So the question asks, how many solution sets are there? Okay, let's try this. This is a type of combinatoric question. Okay, so let's try to solve this together. So first thing first, if I do not have x smaller than y smaller than z, just number of solution set such that x plus y plus z is equal to 203. Okay, without the constraint, x smaller than y smaller than z. So okay, as long as x, y, z are positive integer with the sum of 203, how many solution set do I have? That would be, because x, y, z starting from 1 onwards, right? So you have 3 variables, that means you have 2 separator. Okay, so that means that this 203 minus 1 out, right? So that will be just 202. Choose 2. Okay, this is the number of solution set of some positive integers. Okay, add up together to get 203. So you just need to decrease by 1 because here you have 3 variables. Okay, so that's, you have 202. Choose 2. So that of course is 202 times 201 divided by 2. Okay, which is, you can calculate this. This is 101 multiplied by 201, so that is 20301. Okay, such solution set. But of course this is without the condition of x smaller than y smaller than z. So if you want to subtract out the cases that I do not want, okay, so what are the complement cases to x smaller than y smaller than z? So one case is if 2 of them are the same. Okay, x equal to y. If 2 of them is the same, let's say x is equal to y, so that means that the constraint fixed sum at 203 will give now 2x plus z is 203. How many solution set do you have here? X. Alright, x technically you can take all the way from 1 to all the way until 101, correct? That means 2x is 2 all the way until 202. Okay, and z is just whatever, how much the top up to 2x to get 203. So that means that in this case you would have 101 solution set. Okay, solution. If you have the constraint of x is equal to y. Of course it's similarly, right? Similarly for the 101 solution for the case of y is equal to z and z is equal to x. Okay, it of course is the same thing. Okay, so of course you do not have the case of x equal y equals z. Okay, so it kind of makes this question a little bit easier. If x equal y equals z, there's no such case, right? Because if it's equal, it cannot add up to get 203. Okay, This one no solutions. So what I mean is this, okay? The total cases, so that means the answer is, the total cases is 20301. Okay, this is without this constraint. But if I want to subtract out what I do not want, it's the case of whereby two of them are the same. Okay, so if x and y is the same, you would have 101 solution. So then I also need to exclude the case of y and z is the same, and of course I need to exclude the case of z and x are the same. So I need to minus each case is 101. Okay, but I still need to divide by 3 factorial. Why? Because even though I have the solution, let's say 1 to 200, okay, so these three numbers are already all different, correct? But I only want this is fixed, right? Of course 200 is also a solution, right? But it's not in a strictly increasing order. If I haven't divided by 3 factorial yet, it's just that three numbers are all different. Okay, so I divided by 3 factorial to get the order x smaller than y smaller than z. Okay, so this calculation you would get at the end, you get 3,333. Okay, so this will be the answer. We have completed this lesson. Thank you for watching this video. I hope you have enjoyed today's lesson. Goodbye and see you again in another lesson.
If you would like to learn more from these tutorials, please smash that like and subscribe button.